Welcome everyone. I'm Scott Chronic with America Makes. I'm here with Tim Osborn from the University of Dayton Research Institute. Tim is a project manager on one of our mammals projects through the mammals program. That's the maturation of advanced manufacturing for low-cost sustainment. He's focusing on replacement parts on aircraft, low-cost sustainment, non-critical flight parts. I'll turn it over to you, Tim. You can talk about some of the parts, and I know there's 3 project focus areas that you're looking at in those part replacements.
Yeah, so this program is really funded by Air Force and America Makes. We've identified a lot of pain points in Air Force sustainment where it's either hard or impossible to source these parts for aging aircraft. So we've identified additive and advanced manufacturing techniques that can alleviate that need by introducing lean inventory control by printing the parts on demand for sustainment. So this program in particularly is a collaboration with 3D Systems, Northrop Grumman, Lockheed Martin, and we're working with Aptiv as well. We are using the emerging new Figure 4 technology by 3D Systems. We're evaluating it for hard-to-source sustainment parts in aerospace. So,
can you talk a little bit about that Figure 4 technology and what the technology actually is in regards to 3D printing?
Yeah, so the Figure 4 technology is a DLP technology that 3D Systems has commercialized this year. This program is driving aerospace-specific resins and materials through the Figure 4 process and into the aerospace environment.
Okay.
So I have some examples here of parts families that we're going after. So things like hard-to-source electrical connectors, wiring grommets, spacers. The Figure 4 technology has the ability to print with elastomeric materials, so it enables this whole kind of, conformal elastomeric type parts. The area I'm most excited about is internal cockpit panels and knobs for aerospace. So you look in the cockpit of an aircraft and you're seeing all those backlit, illuminated panels and knobs and controls, traditionally made from acrylic materials that are clear. This program is going to go directly after replacing some of those legacy components with Figure 4 printed, 3D Systems developed resins, and UDRI's on the program to run those parts and materials through the gauntlet of testing to prove that they're worthy of one day being on an aircraft.
What's some of the challenges in regards to some of the parts? I know some of the parts, I mean, they're not just polymer, they have the D metal insert for sustainability.
So there are a lot of challenges from the materials side, getting flame, smoke, toxicity, passing burn testing, UV exposure testing, and that's what UDRI is doing, is running it through that gauntlet of tests for each specific part family. So yeah, there's a lot of materials issues that this program hopefully will overcome. There's a lot of innovative solutions that we're uncovering. Competing with injection overmolding, where you have like a metal insert placed into a plastic knob, for example.
Right.
Exploring unique approaches to do that in process in a 3D printing technology. All things that are coming to light in this program.
Right. Is there a focus in actually testing these parts? Who are you working with and actually doing test fits and such?
Yeah, so we're working closely with Air Force, and we're working to transition this technology through our sustainment and technology transition partners at UDRI, who are on the ground every day working with the aerospace engineers at the Air Force to get these actually on the plane, get feedback from the ALCs even, to where we're comfortable implementing these Air Force-wide once we demonstrate the feasibility here.
Is there any discussion in regards to where they see this actually being implemented in the future, timeline-wise? Is this like a, 6 months, a year, 2 years out that they think that these parts will actually go on aircraft? Or?
I won't speak. I won't speak for them, but
with your knowledge of where you think.
My personal opinion is each part family is going to differ greatly. So electrical connectors, there's about 90 tests that this is going to have to go through before it gets on an aircraft.
That's more complex than a knob.
This is the most ambitious program goal.
Okay.
So things like a hydraulic tube spacer, that is ready to go to test fit, today. And then probably the interior cockpit panels, that's kind of in between in difficulty level.
And the idea of these replacement parts are the fact that a lot of these parts on these aircraft are no longer available from their original OEM.
Right.
Drawings are not available anymore. So there are no inventory parts to replace these.
Exactly.
So new innovative technology has to be developed to replace the parts,
exactly.
or the plane becomes grounded.
Yep. So we're competing with no quotes or does not exist, or I'm going to have to spin up to produce this again, and not a lot of people want to do that. So this is a perfect place for additive to really show what it's good at, and I'm excited to see where it goes.
And the Figure 4 technology would be more located at a sustainment location rather than in the field. It's not really a field application, it's more sustainment, right?
Yeah,
like at the centers.
I think, and correct me if I'm wrong, but I think the Mammals program is designed to identify emerging technologies and then take it the next step to, okay, we've identified value here, now how do we get it on the ground at the repair sites?
Right.
Right. I think that'll be year 2 of the program, is really focusing on transition strategy for part families that make sense.
Sounds good. Well, Tim, thanks for your time. And
all right. Thank you.